Hi there, my name's Charlie,
And I'm Ryan.
and we are going to present our recycling robots that we made. Oh, there we go. So currently, a lot of the trash in landfills is recyclable. It's something that a lot of people know. Every day, you throw out things that are recyclable because there's not a lot of infrastructure in a lot of places to help recycle things. A lot of that comes from not having a proper way of sorting that garbage. If it's already mixed in with the trash, getting it out is more trouble than it's worth for a lot of companies. Now, the best way of being able to, sort that garbage is definitely to have individual people sort their own garbage. However, that's not going to happen for a while until public opinion changes and until it becomes a lot more worth it. The issues with current methods include that machines that exist right now only sort by size, which doesn't work for different types of trash, and otherwise humans are sorting it, and that has a really negative impact on their health, which several studies have shown. So the requirements for this project are that we need to be able to sort waste into recyclable categories, glass, plastic, metal, and not put humans into that harm's way, and have a much lower margin of error than current methods have. And so the design requirements reflect that. It needs to be able to travel with the waste so that it can actually bring the different categories back to that collection point. It needs to be able to identify those main three categories that can be re-recycled: glass, plastic, and metal. And it needs to be able to leave those non-recyclables like food or paper, which is recyclable, but not very many times. It needs to be able to leave those behind. So the human impact of this would be pretty vast. It would be marketed towards active waste facilities that already are sorting those things, just at a less precise level. It would be very attractive to green politicians and other people who want to improve their environmental image. It could also be modified for home use, so those people who don't sort their garbage because it's, too much effort or whatever, could begin to do that a lot more easily. It would probably reduce those jobs in waste sorting. However, that wouldn't necessarily be a bad thing due to the fact that those are very harmful on people's health. And it would increase recycling jobs as a larger volume of recyclables are able to be processed. So the two different robots we have for the two members of our group are a sorting robot, which sorts by color using a claw and just drops recyclables into different containers, and it would move left and right across current conveyor belt systems.
And the other robot would be a transit robot. So that robot would collect the full waste containers from the sorting robot, replace them with empty ones so it could keep working, and then deposit the full waste containers at different collection points depending on the type of waste.
All right, so the sorting robot, as aforementioned, would move left and right over a conveyor belt. It has distance sensors on the side to make it be able to see where the wall is and when it has to turn around. It has a claw for sorting, and that claw has a color sensor that's going to be represented by a photoresistor because the color sensor that we are referencing is not available in Arduino. And it has servo motors in the claws to control them, and force sensors under the bins to let Ryan's robot know when one of the bins is full. I was only able to have one due to limitations, but there would be three in a finished product. So this is a mechanical design. You can see that there is a claw and three different bins. The claw will go to different angles to be above those bins and then drop the trash into those bins. On the underside, right here, we have an Arduino, the 9-volt battery, a gear motor that only goes left and right in those two dimensions. There are also these two blue things on the sides represent the distance sensors. So the claw is just a little bit more complicated. So we have this is the overall claw. You can see these two boxes are the two sensors. One is going to be a distance sensor, one is that color sensor. The yellow boxes are servo motors. So when it sees something, the servo motors change their angle and grab the trash. And then the arm right here in the elbow, there's also a servo motor, and that's going to move the arm to different angles to drop the trash off. So this is my circuit design. As you can see, I've got three distance sensors, one for each side and one for the claw. There are three servo motors, which have already been briefly explained. We have this photoresistor to represent the color sensor, and a force sensor, and the gear motor. Right, and now I get to show you the real deal. All right, so here we have my code. We've got, oh wait, hang on. Need to show you my activity chart first, don't I? All right, so basically the robot is just going to check each wall, see which side the wall is on, because it's going to start on one side. If it's on the left, it'll move. It'll move right. If it's on the right, it'll move left. And the code is the same either way. So it'll then check the weight. If the weight is high enough, it will signal Ryan's robot, and Ryan's robot will come over. So that's the output. The inputs are weight. So when the weight is 0, it'll begin going again after Ryan's robot has replaced the bins. Yeah, and then it will continue to check if the distance by the claw is close enough that there's something within range. If it is, it'll close the claw, check the color, move it to its respective bin, and drop it. After that, it will go left or go right, depending on which side it was going. And then it'll check the weight again and continue going through that. All right, so here we have my code and my simulation and everything. And I will say the photoresistor makes it so you can't see what happens when it abandons it, but there is code built in for when it abandons it. So I've got all my inputs here, got the setup with all the pins and the servos, and the different distance functions are at the end. And it will continue to print all of the inputs that it gets from its environment. So basically, this is the the left function and the other one is the right function. They're the same other than which direction they're going. So it will check all of these inputs, and then you have these, all of the different formulas. So here we can see the thing actually working. So currently, photoresistor is below a certain level. Let's see. If we move the clock closer, it will start sensing, okay, it's below the level, which means it's, I believe it's glass, and you can see the arm servo moving and the claw servos moving to the correct positions. And if I move it higher, you can see that the arm servo is going to move to a different angle. So it's a much shallower angle. And then if I move this out again, it knows that there's nothing by the claw, so the servo motors stop moving. And then currently the motor is going negatively because it's going in one direction. When I move my things the other way, it will start going positive because it's going in the positive direction. All right, and then if I move my weight higher, you can see that it's stopped and it continues to print, come get your garbage to Ryan's robot. And when it goes down again, there we go. And now my motor is going again. All right, now it's Ryan's turn.
So for the transit robot, this is the design for that one. You can see it has a set of arms on either side. These are for picking up the full containers from the sorter robot, and then it'll have an empty container on the back here. And so it'll pick up the full container with the front arms, rotate its midsection, and drop off an empty container so the sorter robot can keep working. It has a little box on top that houses the sensors. I made them look like eyes because that's just what it looked like to me. But it's got a distance sensor and then a wavelength sensor. And then it has a gearbox for each set of wheels so that it can facilitate turning as well. Here you can see on the circuit design, like I said, a gearbox. So this would be the right wheels and the left wheels, the front arm, the back arm, and then the servo here would be for rotating the midsection. It has the distance sensor so it can avoid obstacles while it's traveling between the sorter robot and the collection point. I have an IR sensor because I used an IR remote to sort of show the different inputs that it would be getting from the sorter robot. And then a photoresistor as a stand-in for a wavelength sensor. Then for the flowchart, it would start over at the collection points and it would wait to get a notification from the sorter robot that it has a full waste container. And then it would begin to travel to the sorter robot using its distance sensor to avoid obstacles on the way over. Once it gets to the sorter robot, it would have gotten a notification that would have told it the wavelength of the waste that it's picking up, whether it's glass, plastic, or metal. It'll scan the first container. If it finds the right wavelength immediately, then it'll start to move forward and to pick it up. If it doesn't, then it'll rotate and it'll move around to the next container and scan that, and it'll keep doing that until it finds the container with the right wavelength it's looking for. Once it finds the right wavelength, then it'll move forward, it'll pick up the container, reverse, rotate its midsection around, and then move back forward and deposit an empty container so the sorter robot can keep moving. And then it'll back up, rotate its midsection back around, and start to return to the collection point. Again, using its distance sensor to avoid obstacles on the way over. Once it gets to the collection point, then it'll rescan the container just to double check what wavelength it has, and then depending on what wavelength it finds, it'll either basically there's going to be 3 collection points. It'll either move forward or turn right or left to go to each respective collection point, and it'll deposit the waste container and then pick up a new empty container that's waiting there, and it'll await further instructions to go back to the sorter robot. We go to my code here. So I use sort of the same setup that we learned for the robot to avoid obstacles. I have all the inputs and outputs enabled and defined up here. And then if you go down here, I have all the behaviors, going forward, turning left, turning right, defined down here so that I can just use them in different variations for the actual inputs. And then right now, if we start, if I do 1, so that would be just a notification that it got that there's a full waste container for it to pick up. So you can see it move forward, it avoided an obstacle on the way over, and then it's continuing to move forward to the robot. Once it gets to the sorter robot, it'll start to scan for the different wavelengths of the containers. So you can see it turned, it didn't like that first wavelength, turned again, and then it finally found the right container that it was looking for. Here it'll start to pick up the right container, it'll reverse, it'll turn its midsection around, go back and place the empty container, and then reverse and turn its midsection back around so that the full container is back in front of it. And then it'll start to return back to the collection point, avoiding obstacles. And then once it gets to the collection point, it'll rescan the container. Here it decided to go, it goes to the right collection point. If I change the different light on it would have been wavelength, but for the light level here, it'll go to a different collection point, either right, left, or middle. And then the last behavior is just it depositing its full container, rotating its midsection around here to pick up the new empty container, and then resetting and getting ready to go back to the sorter container next time it has a full container. Which is sort of what I already went through for the flowchart as the swarm, which is just the sorter container is going to be sorting through waste. Once it has a full container, it'll notify the transit robot, which will then come over, pick up the full container, replace it with an empty container so it can keep working, and then go deposit it at the collection points and await further instructions. In summary, like we mentioned earlier, this would eliminate a lot of the dangerous jobs and introduce even more jobs to maintain and repair these new robots. And it would have a positive environmental impact just because it's increasing the effectiveness that we can sort through waste. As far as improving it, one of the biggest improvements would be our design works on a conveyor belt system. So the sorter robot just travels along the conveyor belt and sorts through waste. But if you could get it to where it could just freely roam around a landfill and just sort of sort through it as it goes instead of having to be fed waste through the landfill, that would just make it more efficient and more effective. The best way to sort through waste is for each individual to sort of police themselves and sort through the different types of waste before it even gets sent to the landfill. But these robots would help bridge that gap until that's more widespread and more people are doing that.
All right. Thank you so much for watching. I hope you enjoyed.
Thank you very much.